It's time for an autopsy, and this is a light I put up in my brother's workshop not that long ago, and it's already failed. And if you're looking, it's powered at the moment, you probably won't see this, but the inside, the middle row of LEDs is just glowing dimly, and the outer ones are even dimmer still. So I'm wondering if it's the LED that's failed in this, or the power supply. I'm thinking it may be the power supply, but the only way to find out is to actually, well, the easiest thing to check is to take the front cover off and check the LED first. So the reason for that is that the power supply is potted, so the only place we can really test the output is across the LED. So let's get the cover off it. So I've just unplugged it, and we'll get the screws out. If the LED has failed, it's easy enough to change the LED. If the power supply has failed, then I probably have 10-watt power supplies here, but that does give the option to modify the light and actually stick a lower power supply in it. So let's get the cover off. Oh, it's glued on. That's annoying. It's been glued on. Let's see if we can break the seal with a knife. It's that sort of goopy silicone stuff. They've just obviously had problems with water ingress, so they've just decided let's plaster all over the whole thing. Is that going to... yeah, that's better. That's better. It does have a seal, that's strange. It's got the classic 2 diagonal screws holding the reflector on. So a couple of scenarios here. I could measure the voltage across the LED, and it could be a sort of floating 12 volts, and the LEDs could just be have the bonds could have broken, they could just be passing a bit of current, or it could be really low, it could be around about the 7 or 8 volts, which would suggest that the current was being limited by the power supply, but it had really gone to a low level. So let's plug it in and get the meter in and measure the voltage across the LED. You have to keep in mind that you just never know what the circuitry is in these things. It may or may not be isolated, so let's play safe and not poke it with our bare fingers. So this is set to 20 volts. The voltage across it is very high open circuit voltage. Yeah, that would suggest that this power supply in here, this LED has failed, and the power supply is just floating open circuit. So I wonder what. I wonder if it's designed for the 12. I mean, I'd normally expect that power supply, that LED just flashed as the voltage went down there. I would normally expect these LEDs to be configured as either the 9 chips in series for a 27 volt supply, which that sort of supply did suggest that is the case, or I would expect to see the 3x3 array of LEDs, and the voltage would normally have been lower. So I have a sneaky feeling this might be all 9 chips in series power supply, which kind of fits the nature of the fault, that my brother said it started pulsing at first, and that would suggest that if the whole thing was pulsing, it would suggest that there was a bond problem and that all the LEDs in series were given the problem. But what kind of threw me here is the fact the middle LEDs were brighter and the 2 outer ones were dimmer, but it must just be bad matching, although they are all in series, it must just be different LEDs. So what options do I have here? Well, I've got plenty of LEDs, but they're all 12 volt. Pretty sure they're all 12 volt. I'm just going to take a look at my LED collection. This is a... yeah, this is a 12 volt LED. So the other option I've got here is I could change the power supply inside it. I could put in something deliberately. I could put something low, like a 3 watt power supply. These little 3 watt power supplies are commonly used in spotlights and things like that, where you've just got 3 1 watt chips in series. And if I was to change the LED for a new one that is the classic type, I just reached up here and said, is the classic type. The first ones I grabbed were completely non-classic LEDs. These ones are the standard 12 volt LED, roughly 12 volt, which have the 3x3 array of chips. If I was to put this in, it would just, basically it would run them at lower current they'd normally experience. It would be only 100 milliamps per row, which would make them last for ages. I'm quite tempted to do that, quite tempted to whip the other power supply out of this, put a new LED in, the 12 volt LED, put this in the back, and then that would give me a an interesting, I'll put a colour in, something like blue. In fact, you know what? I've got some interesting LEDs up here, including these ones. This one has really big chip blue. These ones came from Babeo shop. 10k white, 20k white, warm white and blue, and the difference between the whites is that the phosphors on them are, well, it's actually the quantity of phosphor more than anything else. The blue has just massive chips in it, and I've tested all these and they all came out pretty well in terms of the LED matching. But the white LEDs, which use the same large chips, seem to have a different quantity of phosphor. So this one's got barely any, and it produces an absolutely dazzling, brilliant blue light. This one is a bit more phosphor and produces less. I mean, it's white light that's coming out, but it's just really biased towards the cold end of the spectrum. And then there's this one, which is plenty of the warm white phosphor, and it puts out a very warm white. So decisions. I might be tempted to stick in one of the, oh no, I know what I'm going to stick in. Decisions indeed. I'm going to stick this one in. This is a growlight style LED. And it's quite a broad spectrum LED, but it's biased towards, if I get my power supply here, it's biased, I'll turn the voltage down, then creep it up until it just starts forward conducting. This one is biased towards a sort of like the plant growthy type thing, so I'll just ramp it up. But it puts out this lovely magenta colour. It's this brilliant, warm, pinky magenta. So I might actually stick that in. That could be quite interesting. I'm going to do that right now, in fact. So let's get the original LED out. Let's desolder the leads. Solder, there's solder. It is very easy to change the LEDs in these things. You just have to be aware with the 10 watt LEDs, you do get that double variety. You get the version with the 3x3 array of chips, and the other ones where all the chips, although they're visually in a 3x3 array, they're actually wired in series, and the combined forward voltage is more closer to about 27 volts, roughly 3 volts per chip. So let's take out this Duff LED. And let's put in my new LED, which won't operate with that power supply, so I'm going to have to change that power supply. So I'll get a bit more heatsink compound in the back of this. Just a wee tiny drop right in the middle, so as it, that's actually a bit too much, but not to worry. So that as it's pressed down, it all squishes out, and hopefully will, oh, that wasn't a very good start. Squishes out, oh, yeah. I'm not doing very well here, 1 moment please. Paper towel. I can actually wipe this off once it's in position. So let's sit this into position, hook it under that screw over there. They've just kind of pinched at the corners. Diagonal screws, as is so common with these things. I guess that might actually, well, I suppose it makes manufacturing tolerance lower, and it also maybe gives a little bit of expansion and contraction give. I'm not really sure if that would be really the case. There's not going to be so much thermal stress now because the LED is going to be grossly underrun. It's not going to be run anywhere near its rating now. It's a 10 watt LED, it's going to be run at 3 watts if I put this other power supply in. So let's get the back off this. Let's keep those screws over there. I've got automatic exposure control on, haven't I? So it's making the video look absolutely ghastly because it thinks this is white. Oh well, ghastly video it is then. I've already had this open because I already put a new lead in it, a new flex, which is good because the flex is long enough I can just put a plug in this and use it as a decorative light. It would be nice if Apple had generously put a feature in the iPad to actually let you lock the colour temperature, you know, tungsten fluorescent, but they didn't. Oh, right, okay. Ew. Right, so the power supply in this one is a little heat shrink blob thing. This one must have come with long leads then. This one must already have come with long leads. Oh, that's interesting. Right here. So I'm going to cut that off, make double checks it's unplugged first. I may actually reuse these leads then, these little silicon leads. Yeah, I'll reuse them. Let's get the meter out of the way. And since I can, I may just solder these leads directly into that little tiny power supply I've got. Where is my tiny little power supply? I had a tiny little power supply. There it is. This whole project is slightly pointless. I'm not sure if I'll need a decorative light, but then again, who cares? It's kind of fun to do. So we've got the DC output here, but I'm just going to make a wee red dot to remind me. And I'm just going to tack the leads on the printed circuit board side. So we've got the AC going in here, which I'll just rip the leads out right now with a bit of solder. So a wee splash of solder in that one and whip that lead out. That means I don't have to put the leads into a joint, because I can just bring them straight in from the flex into the unit. Wire strippers. Keep the wires deliberately short. Ooh, it is very thin flex. Maybe I'll put a 3 amp fuse in that plug, or check it has got a 3 amp fuse. Actually, it's just stuffed into the quick block, so it doesn't have any fuse at all. I wonder if it's the aluminium core cable or if it's actual solid copper. Who knows these days? And then I'm going to stick that wire on there. And this wire on here. Making sure I've not passed it through the seal in some random way that I'm never ever going to be able to get the seal back on again. Looks pretty good. Now let's whip the DC side cable off. So I'm just going to flow some fresh solder on. If you're desoldering existing, particularly this sort of lead-free solder type things, it's always useful to flow lead-based solder on. This is standard 60-40 solder, which is a mixture of lead and tin, and it's got flux. The electronics solder has flux cores up the middle, which also, it basically the flux has the job of, it kind of mates the solder onto the surface. It has a cleaning effect, makes for a better solder joint. So I'm going to strip the very tips off these, not going to strip them too long at all. Yeah, I have to say the colour, because of the MDF background, the colour the iPad is currently recording, because I didn't lock it off, is just hideous. It's a very ghastly greenish colour. So let's solder this wire onto the negative terminal. That's quite rigid. This wire is very stiff. I thought it was I thought when I first saw it that it was a silicone cable, but it's not. So I wetted the tips of these wires first, and the pads already had solder on them, so it's just really reflowing them together. Now what I could have done for space saving, actually, is that going to fit in there? Yes, it is going to fit in there. I could actually have just put heat shrink around this, but I'm not going to. I'm going to put this cover back on. This says mains in this end. As I say, the advantage of using a 3-watt power supply, it's so common, they're about 99 pence on eBay, it's worth just buying them just to have one spare. The advantage of that is that, you know, this light is going to last for, the LED is not going to be stressed in any way, it's going to last for a very long time, even if it's a fairly dodgy LED. So if I mush that into there, there's plenty of room now. Actually, you know what, let's solder these leads on before I do that, because then I can, oh, there's actually loads of room in here to tuck them away, isn't there? I'll also get rid of that excess heatsink compound I've squished everywhere in my usual messy manner. God, I'm so messy at times. Yeah, let's stick the back on this, yeah, it's fine. I can always just lose, it's not going to get very hot inside, so I can just lose the rest of the cable in the front of the light. So I'm going to try and sit that seal on. And then I'm sure it'll just pop out repeatedly as I try to get the cover back on it. But let's sit this back down like this. Yeah, the seal is just going all over the place. That's okay. It's primarily going to be an indoor decorative light, probably. So let's put the cover back on. I'm so confident this is just going to work, you know. With my 99p power supply. Squish that about until the seal sort of sits into its proper groove. The seal has just not sat into its proper groove. These rubber seals are a pain in the butt at times. There we go. I think that's pretty much it. If it's not it, I'll just surreptitiously hide it from your vision. Hide it from the camera so you can't see I've sat it in badly. No, that's looking pretty good. I like the fact these lights are so modular, it just makes them completely serviceable and modifiable. You know, you can have any colour of light you want. And eBay, well, the cheap LEDs in eBay, it's very variable. Sometimes you get really good ones, and sometimes you get crap ones, but it's very random. The LED sellers that sell the more specialist LEDs, that Babeo shop or whatever it was, what was it? That sells the sort of more specialist colours, they, oh there it is. Babao shop. Because they sell the more specialist LEDs, the quality of the LEDs just seems that little bit better. Another seller I've had good luck with is Sure Display. On the whole, the 10-watt LEDs have been pretty reliable though, except the one that came in this light, which I've just pressed. I've just made a mess of that as well. I've just heatsink compound everywhere. It's what happens. So let's flow some solder onto these leads. We're actually almost there, we're just about ready to plug it in. And flow some solder onto the pads at the end. And mate them together. If you hear the buzzing in the background, it is that it's my Yahoo 8786D solder station. It just makes the transformer quite buzzy. It buzzes when it's off load and then it's quiet when it's on load, so it sort of cycles on and off. Annoyed me at first, but now I'm used to it. As happens. So if I plug this in now, this should work. Yes, it does. It's drawing 3.8 watts. That's quite a nice colour. I do like that colour. That is bright magenta. So I'm going to put the cover on that now. And, well, I would say that's it fixed. That's it modified, might be a better description. So this cover can go... Oh, the reflector would be quite a good idea. Reflector would be a good idea. With its two little diagonal opposing screws. I'll have a go at dropping it completely on the floor. And then afterwards I'm going to strip the insulation off this heat shrink and see what's inside that power supply. I'm guessing, although it's 10 watt, I'm guessing it's going to be very basic. It's going to be similar to what's inside these little generic ones that I've used in this one. So let's line this up with the LED. They're so modular, they're so versatile. I like these lights just partly because of the cases and they're just their hackability, the fact you can just modify them so easily. they're quite enjoyable and cheap as shit is really the best way to say it. They really are just so cheap. It's worth getting to play with. Toys. So this video was originally just going to be a sort of like, which has gone wrong, how to diagnose it, but it wasn't supposed to go in this direction, but as you know, sometimes they just randomly go off at a tangent. Nothing really wrong with that. It's been quite enjoyable. I quite enjoy just messing around and doing stuff like this. It's just therapeutic. It's enjoyable. Right, so yep. Yeah, that's quite nice. That is quite nice. It's putting a modest amount of light. It's only about 3 or 4 watts, according to the meter here. But that's absolutely fine. It's ample. So let's shove that to the side and leave it lit, and take a look at this. So let's use some scissors to get into this. Usually, if I drag the knife across, I end up chopping something. So this is a still working power supply, and it's based round. It's got the traditional bridge rectifier. It's got the little 8-pin chip, but this time the 8-pin chip is a switching power supply chip. That light is now in my eyes. Is it going to be a bright power? Oh no, it's not. I like bright power. LIS 8512B. LIS 8512B. Hold on, I'll just demist this thing. Is that, are you going to see that at all? What have I? Yeah, I've got light on here. No, I don't know if you're really going to be able to see that much there, but yeah. With the usual support components, the current sense, it's probably got the snubber network. I see the snubber network tucked underneath here. Beefy capacitor, 10 microfarad, but then it is a 10 watt light, so it's going to require that bit extra. No real major filtering in the input, and then the output is really just, it's the diode, it's the capacitor, and it's got a little load resistor across it. And it does seem to have separation anti-tracking slots in there. It says JD LED power, 10 watt. Useful. I'm going to write in this one, I'm going to write it 28 volt just for the output voltage. 28 volt. I'm going to connect that to 28 volts now. 240. I'll just put 240 on as well. Yeah, that solves problems. I'll write 10 watt. Yeah, now I know really what it is now. So yes, well, it went off a random direction, but it was interesting. It certainly looks nice. So that's just basic how you can recover one of these light fittings. You can fit in the new driver, you can fit in the new LED, and by using one of those generic cheapo 10 watt LED drivers, it's still going to put out ample light for a general sort of just ambient sort of finding your way about at night type of light, but it should last a lot longer.